Stand at your front door for a moment, and let the door stand for the sun. At that scale, with the whole sun shrunk to the height of an ordinary doorway, the Earth becomes a small coin. Not a coin lying at your feet. A coin about 200 meters away, 2 full city blocks down the street. So small at that distance you cannot see it at all. Jupiter, the largest planet, is a dinner plate a kilometer from the door. Neptune, the last of the planets, is 6.5 kilometers away, on the far side of town. The most distant machine human beings have ever built, a probe called Voyager 1, launched half a century ago and traveling ever since, has made it about 36 kilometers down the road. And the nearest star, the very nearest one, our sun's closest neighbor in the entire galaxy, would sit 58,000 kilometers from your front door. At the scale where the sun fits in a doorway, the next star along is more than the distance around the whole Earth. That is the neighborhood. Almost all of it is empty. Scattered through the emptiness are 8 planets, a few hundred moons, and countless smaller worlds of rock and ice, all of them circling one ordinary star. The sky above that door is doing what it always does, whether anyone watches or not. So we're going to make the journey once, slowly, from the fire at the center to the cold at the edge, one world at a time, and see what is actually out there. We begin at the door itself. Every culture that ever looked up gave the sun a name, and most of them gave it a throne. The Egyptians rode it across the sky in a boat. The Greeks gave it a chariot. It is not hard to understand why. Nothing else in human experience behaves like the sun, and nothing else matters as much. The plain facts are stranger than the myths. The sun holds 99.8% of all the mass in the solar system. Everything else, every planet and moon and asteroid and comet, every mountain range and ocean and living thing, adds up to a rounding error. It is 1.4 million kilometers across, 109 times the width of the Earth. If it were hollow, about 1.3 million Earths would fit inside. It is not burning, not in the way a fire burns. Fire is chemistry, and the sun outgrew chemistry long ago. It is a ball of hydrogen and helium so massive that its own gravity crushes its core to a temperature of 15 million degrees Celsius. And at that temperature, hydrogen atoms are forced together and fused into helium. Every second, the sun converts about 600 million tons of hydrogen into helium. In the process, 4 million tons of matter simply cease to be matter. They become light. That light does not leave easily. The inside of the sun is so dense that a particle of light born in the core cannot travel more than a fraction of a centimeter before it is absorbed and re-emitted in some new random direction. It staggers outward step by tiny step, a drunkard's walk through a crowd 100,000 kilometers deep. The journey from the core to the surface takes somewhere between 10,000 and 100,000 years. Then, having finally reached the surface, the light crosses the 150 million kilometers to Earth in 8 minutes and 20 seconds, which means the warmth on your face on a summer afternoon is old light. It left the heart of the sun before the pyramids, before farming, perhaps before the end of the last ice age. It spent all of recorded human history working its way to the surface, and then reached you in the time it takes to make a cup of coffee. The surface it escapes from, the bright disk we actually see, is a comparatively mild 5,500 degrees. Seen up close, it is not smooth. It boils. The whole face of the sun is divided into granules, rising cells of hot gas, each one roughly the size of a large country, and each lasting only minutes before it cools and sinks and is replaced. Here and there the boiling is interrupted by sunspots, darker blotches where magnetic fields choke off the heat from below. A sunspot looks small against the disk. Most of them are the size of the Earth. The sun does not even rotate like a solid thing. Its equator turns once in about 25 days, while the regions near its poles take more than a month, and this slow shearing winds the sun's magnetic field tighter and tighter until it snaps and reconnects in flares and vast eruptions. And from the whole surface, all the time, the sun leaks. A thin wind of charged particles streams off it in every direction at hundreds of kilometers per second, flowing out past every planet. That wind matters more than it seems. It inflates an enormous invisible bubble around the entire solar system. And at the very end of this journey, out past the last of the planets, we will reach the wall of that bubble, the place where the sun's breath finally fails. The sun is about 4.6 billion years old, and it is middle-aged. It has enough hydrogen left to go on shining, much as it does now, for roughly 5 billion years more. On the scale of a human evening, nothing about it will ever change. It will burn with perfect patience through every night of every life that will ever be lived on Earth. We step away from the fire now and head outward. The first world we meet is a small one, keeping close to the flame. Mercury is the smallest of the planets and the fastest, and both facts come from the same cause. It lives closest to the sun. The Romans named it for their messenger god, the one with wings on his heels, because it sprints. Mercury circles the sun at 47 kilometers every second and completes a full orbit, a full year, in just 88 days. Any faster and it would fly out of orbit. Any slower and it would fall inward. It is a world about 4,900 kilometers across, only a little larger than our own moon, and at first glance it looks like the moon's twin. Gray, airless, and covered from pole to pole in craters, a face that has kept the record of every impact for 4 billion years because there is no weather to erase them. The largest scar, the Caloris Basin, is a crater about 1,500 kilometers wide, gouged out by an impact so violent that the shock waves traveled around the entire planet and met on the far side, where they shattered the ground into a jumbled, hilly terrain that geologists, for lack of a better word, simply call weird. But Mercury is not a moon. It is denser than it has any right to be, and the reason is hidden inside. An enormous core of iron fills about 85% of the planet's radius. Mercury is essentially a cannonball wearing a thin coat of rock, and one theory holds that it was once a larger world whose outer layers were stripped away by a colossal collision in the solar system's violent youth. If you could stand on its surface, and this is imagination now, the strangest thing would not be the cratered ground. It would be the sky. With almost no atmosphere, the sky above you would be pitch black in the middle of the day, stars invisible only because your eyes were narrowed against a sun 3 times wider than the one we know. Mercury turns so slowly and moves along its orbit so quickly that the two motions nearly cancel. A single day there, from one sunrise to the next, lasts 176 Earth days, which means the planet circles the sun twice between one dawn and the next. And in certain places at certain times, the planet's speeding orbit briefly outruns its own slow spin, and the rising sun stops in the sky, sinks back below the horizon, and then rises a second time. Those long days and nights produce the most extreme temperature swings of any planet. The sunlit ground climbs to 430 degrees Celsius, hot enough to melt lead and tin. The night side, with no air to hold the warmth, falls to 180 degrees below zero. A 600-degree difference between afternoon and midnight on the same patch of ground. And yet Mercury holds one genuine surprise, discovered only in our own time. Near its poles there are crater floors that sunlight has not touched in billions of years. And when a spacecraft called Messenger mapped the planet in the early 2010s, it confirmed what radar had hinted. Those permanently dark hollows are among the coldest places in the inner solar system, and they are full of ice. Frozen water, probably delivered by comets, surviving a few kilometers away from ground hot enough to melt metal on the closest planet to the sun. Mercury keeps its secrets close, and it keeps them in the glare. From Earth it never strays far from the sun in the sky, a brief spark in the twilight that many people have never knowingly seen at all. The next world along is not like that. The next world is impossible to miss. Possible to miss. The ancient Greeks knew Venus as 2 different objects. There was Phosphorus, the morning star, which rose before the sun, and there was Hesperus, the evening star, which lingered after sunset. It took time, and probably a borrowed idea from Babylonian astronomers, for the Greeks to accept that the two were one, a single brilliant wanderer swinging from one side of the sun to the other. Nothing else in the night sky, apart from a moon, comes close to its brightness. Venus can cast faint shadows on a truly dark night. It has been mistaken for an aircraft, a searchlight, and any number of unidentified objects. The reason it blazes is simple. It is wrapped completely and permanently in cloud, and those clouds reflect most of the sunlight that touches them straight back into space. For centuries, the clouds let people dream. Venus is almost exactly the Earth's size, a twin, just 12,100 kilometers across to our 12,700. It is our nearest planetary neighbor. Astronomers of the 19th and even the 20th century imagined steaming jungles under the cloud deck, warm oceans, perhaps life. Right up until the first spacecraft arrived, the swamp planet was a respectable guess. The truth ended the dream in an afternoon. Venus is the hottest planet in the solar system. Not Mercury, which is closer to the Sun. Venus, at nearly twice Mercury's distance, is hotter everywhere, all the time. The surface holds steady around 465 degrees Celsius, day side and night side alike, pole to pole. Lead would run liquid on the ground. The cause is the atmosphere. Venus is smothered under an ocean of carbon dioxide so deep and so heavy that the pressure at the surface is 92 times the pressure on Earth, the same crush you would feel 900 meters down in our sea. Carbon dioxide traps heat, and on Venus the trap closed completely long ago. Sunlight filters in. The warmth cannot get back out. Astronomers call it a runaway greenhouse, and they study it with a certain professional unease because it shows what the same ordinary physics can do to a world the size of ours when the balance tips. The famous clouds are not water. They are droplets of sulfuric acid, drifting in layers 20 kilometers thick. Acid rain falls from them constantly and never lands. The lower air is so hot that every drop boils away again kilometers above the ground. Rain that spends its whole existence falling and never arrives. Venus also turns the wrong way. It rotates backwards, east to west, and it does so with almost unbelievable slowness. It spins once in 243 Earth days, which is longer than its own year of 225. The day outlasts the year. If you could watch from the surface, and no one could for long, the sun would be a dull glow behind permanent orange overcast, rising in the west, taking months to cross the sky, and setting in the east. We know what that surface looks like because, remarkably, people have photographed it. Through the 60s, 70s, and 80s, the Soviet Union sent a long series of probes called Venera. The early ones were crushed or cooked before they reached the ground, and each new attempt was built like a deeper diving submarine. Venera 7 reached the surface in 1970, the first machine ever to land on another planet and speak. In 1982, Venera 13 landed and survived for 2 hours and 7 minutes. And in that stolen time, it sent back color photographs. They show a plain of flat, cracked volcanic rock under a heavy amber sky, lit like a late afternoon before a storm. Somewhere on that plain the lander still sits, a Cold War artifact slowly dissolving on the floor of an acid ocean of air. One more detail, and it is a gentler one. About 50 kilometers up, above the crushing pressure and below the coldest cloud tops, there's a layer of the Venusian atmosphere where the temperature and pressure are almost exactly those of a spring day on Earth. It is the most Earth-like environment anywhere in the solar system beyond our own sky, and it is in the clouds of the least Earth-like world. Some scientists have seriously imagined floating stations there, drifting forever on the acid wind. Venus is the planet Earth might have been. The next world on the journey is the one it became. We will not stay long here. This is the one world in the solar system you already know from the inside, but it is worth seeing once from the outside the way the journey sees it. On Christmas Eve of 1968, 3 astronauts aboard Apollo 8 became the first human beings to orbit the moon. They had been sent to photograph the lunar surface, and they did, frame after frame of gray craters. Then the spacecraft came around the moon's far side, and through the window, over that dead horizon, the Earth rose, blue and white and impossibly vivid against the black. The astronauts scrambled for a color film magazine, and the photograph they took, Earthrise, became one of the most reproduced images in history. "We went to the moon," one of them said later, "and what we discovered was the Earth. From space, the first thing the Earth is blue. 71% of its surface is ocean, and it is the only place in the solar system where liquid water is known to rest openly on the surface today. It sits at the comfortable distance from the sun, in a narrow band where water neither boils away, as it did on Venus, nor locks up in permanent ice. On the sunlit side, the oceans throw back the light. On the night side, the continents are veined with the glow of cities, the only artificial light on any world we know. The atmosphere that keeps it all alive is almost invisibly thin. Seen edge-on from orbit, it is a fine blue line hugging the curve of the planet, proportionally thinner than the skin on an apple. Every storm, every sunset, every breath ever taken has happened inside that line. The Earth also travels with an oversized companion. Our moon is enormous for a planet this small, fully a quarter of the Earth's diameter, and it is more than scenery. Its steady pull acts as a stabilizer, keeping the tilt of the Earth's axis from wandering chaotically over millions of years, which has kept the seasons and the climate steady enough for life to take the long view. 2 decades after Earthrise, the departing Voyager 1 probe was commanded to turn its camera back one last time, from 6 billion kilometers out, and photograph its home. In that image, the Earth is less than a single pixel, a pale blue suspended in a shaft of scattered sunlight. Every human being who has ever lived there. That is how the rest of the journey will regard it. A small bright point, falling steadily behind. Ahead of us now is the last of the rocky worlds, the red one. Mars is red because it is rusting. The soil is rich in iron oxide, plain rust, ground fine over billions of years, and there is enough of it to tint the whole planet the color of an old key. The ancients saw that color with their naked eyes and thought of blood. Mars carries the name of a war god in culture after culture. Up close, it is not the color of blood at all, more of a butterscotch, a dusty orange-brown, under a sky that in full daylight is the color of caramel. It is a small world, about 6,800 kilometers across, roughly half the width of the Earth. And of every world on this journey, is the one where you could most nearly convince yourself you were home. A Martian day lasts 24 hours and 37 minutes, so close to our own that the people who drive rovers there simply call it Sol and live by it. Mars has an axial tilt almost identical to Earth's, so it has seasons, springs and autumns, each lasting about twice as long as ours, because the Martian year runs 687 days. There are polar ice caps that grow in winter and shrink in summer. There are clouds and frost on the ground some mornings, and dust devils that leave scribbled dark trails across the plains. The familiarity is a thin layer over a world of extremes. The Martian atmosphere is mostly carbon dioxide and astonishingly thin, less than 1% of Earth's pressure at the surface. It offers no real protection and holds little warmth. On a summer afternoon at the equator, the air just above the ground can reach a pleasant 20 degrees Celsius. That same night, the temperature falls to 70 below zero and beyond, and at the poles in winter it drops past 120 below. Every so often, dust storms grow until they swallow a region, and occasionally the entire planet, veiling every feature of the surface from telescopes for weeks on end. And Mars is a land of giants. Because the planet is small, its crust does not shift and recycle the way Earth's does, so when something builds, it just keeps building. The result is Olympus Mons, the largest volcano in the solar system, nearly 22 kilometers high, about 2.5 times the height of Everest, with a base the size of a mid-sized country. Its slopes are so gradual that, standing on them, you would not perceive a mountain at all. The summit would be hidden beyond the curve of the planet. Not far away, the crust is torn by Valles Marineris, a canyon system 4,000 kilometers long and up to 7 kilometers deep. Laid over a map of the United States, it would stretch from coast to coast. Our Grand Canyon would fit into one of its side channels. The deepest fascination of Mars, though, is written more quietly in its rocks, and it is about water. From orbit, you can see dry riverbeds winding across the southern highlands, branching like the veins of a leaf. There are teardrop-shaped islands, ancient lake basins, and in a crater called Jezero, a perfectly preserved river delta, its sediment fanning out exactly the way deltas form on Earth. 3.5 billion years ago, and more, water flowed here. Rain or snow fell, rivers ran, lakes stood for spans of time long enough to lay down mudstone. Then the planet's fate caught up with it. Mars is too small to hold a thick atmosphere forever. Its core cooled, its magnetic shield faded, and the solar wind stripped the air away over ages until the water could no longer last on the surface. What remains is locked in the polar caps and buried underground as ice. Whether anything ever lived in those vanished lakes is, honestly, unknown. It is one of the great open questions, and it is being worked on right now. Robotic rovers are crawling over the old lake beds as you listen, drilling cores, sealing samples in titanium tubes for a future mission to carry home. One recent visitor even brought wings. A small helicopter named Ingenuity, sent along as an experiment, flew 72 times through that whisper-thin air, the first flying machine ever to operate on another world. Mars keeps two small companions, and there are barely moons at all. Phobos and Deimos are lumpy, dark objects a few kilometers across, probably captured asteroids shaped like potatoes. Phobos orbits so low and so fast that it outruns the planet's rotation, rising in the west and crossing the sky in a little over 4 hours. It is also doomed. Each century it spirals a couple of meters closer, and in about 50 million years it will come apart and briefly give Mars a ring. From the surface of Mars, one more sight deserves mention. The sunsets are blue. The fine dust in the Martian air scatters light in the opposite sense to ours. So as the small pale sun goes down over the rim of Gusev Crater or the hills of Jezero, the sky around it glows a cool, quiet blue at the center of a fading amber dusk. Beyond Mars, the character of the solar system changes completely. First, though, we have to cross a border of stones. On the first night of the year 1801, a monk named Giuseppe Piazzi was at his telescope in Palermo, in Sicily, checking star positions for a catalog, when he noticed a faint point of light that was not on his charts. The next night it had moved. Stars do not move. Piazzi followed it for weeks, fell ill, lost it in the sun's glare, and it took the invention of a new mathematical method by the young Carl Friedrich Gauss to find it again. It was a new world, circling the sun in the conspicuous gap between Mars and Jupiter, and it was named Ceres for the Roman goddess of the harvest and the patron of Sicily. For a while, Ceres was counted as the 8th planet. Then more small worlds turned up in the same gap. Then more. By now we have cataloged, well, over 1 million of them, and the region has a name, the asteroid belt. It is worth clearing away the picture the movies have painted of spacecraft dodging between tumbling boulders. The real belt is mostly nothing. The asteroids are scattered through so enormous a volume that the average distance between one and its nearest neighbor is around 1 million kilometers, more than twice the distance from the Earth to the Moon. A spacecraft crossing the belt will, in all likelihood, never come within sight of a single asteroid unless it is deliberately aimed at one. Every probe we have ever sent through has sailed across without incident. If you stood on a typical asteroid, the rest of the belt would be invisible to you, just stars. Nor is there much substance to it. Add up every asteroid in the belt, all million plus of them, and the total comes to about 3% of the mass of our moon. This is not the rubble of a destroyed planet, as people once romantically supposed. It is the opposite, the raw material of a planet that was never allowed to form. The culprit is the giant world waiting just beyond, whose gravity stirred this region so relentlessly 4.5 billion years ago that the pieces could never settle together. The belt is an unfinished room in the house of the solar system, the bricks still stacked where the builders left them. The bricks themselves are various. Vesta, the second largest, is a dry, rocky body about 525 kilometers across, bright enough to glimpse with a naked eye under perfect skies. Something once struck its south pole hard enough to excavate a crater nearly as wide as Vesta itself. And at the center of that scar stands a mountain more than 20 kilometers high, one of the tallest in the solar system, on a world you could drive across in a long day. And then there is Ceres itself, still the giant of the belt at about 940 kilometers across, so large that its own gravity has pulled it round, which is why it now carries the title of dwarf planet. When the Dawn spacecraft reached Ceres in 2015, it found something odd: brilliant white spots shining from the floor of a crater called a crater, so bright against the gray surface that early images looked like an error. They turn out to be salt, sodium carbonate, left behind where briny water seeped up from inside the little world and evaporated. Salty water inside an asteroid. Even here, in the dry rubble between the planets, the solar system keeps hiding oceans. Crossing the belt takes months, even at spacecraft speeds. On the far side, the temperature falls, the sunlight weakens, and everything ahead is built on an entirely different scale. Everything about Jupiter is excessive. It is the largest planet by so wide a margin that the comparison becomes almost unfair. 140,000 kilometers across, 11 Earths side by side. More than 1,300 Earths could be packed into its volume. Take every other planet in the solar system, all 7 of them, add every moon and asteroid, and Jupiter still outweighs the lot combined twice over. And this immense thing spins faster than any other planet. A day on Jupiter, one full rotation, lasts 9 hours and 56 minutes. The spin is so violent for something so large that the planet visibly bulges at the equator, wider around the middle than pole to pole, like a ball of dough flung spinning into the air. Jupiter has no surface. That has to be said plainly because it is hard to hold in the mind. There is nowhere to land, nowhere to stand, no ground at any depth. It is a world of atmosphere all the way down, hydrogen and helium, the same ingredients as the sun, descend into it, in imagination, and the clouds simply thicken around you while the pressure mounts through decks of white ammonia cloud, through rust-colored layers, through hazes no eye has seen, the air gradually compressing over thousands of kilometers from gas in a hot liquid, until deep inside, under pressures millions of times ours, hydrogen itself is crushed into something strange, a shimmering fluid metal that conducts electricity like copper. An ocean of liquid metallic hydrogen, tens of thousands of kilometers deep. Churned by the planet's spin, that ocean is a dynamo, and it generates the largest structure in the solar system. A magnetic field so vast that if it glowed, Jupiter's magnetosphere would appear in our sky several times the size of the full moon. The face Jupiter shows the universe is banded, striped in parallel belts of cream and brown and salmon that run right around the planet, each band a jet stream wider than the Earth, adjacent bands flowing in opposite directions at hundreds of kilometers per hour. Where they shear past one another, storms curl off like eddies behind a boat. Most storms come and go. One is not. The Great Red Spot is a single storm, an anticyclone, wider than the entire Earth. Astronomers have watched it continuously since the 1830s, and observers as far back as the 1660s recorded a great spot on Jupiter that may well have been the same one. Think of any storm you have lived through. The Great Red Spot has been turning since before your great-great-grandparents were born, and possibly since before Newton. Winds around its edge exceed 400 kilometers per hour. It is, in our era, slowly shrinking, and no one can say whether it is finally dying after centuries or merely changing shape. In January of 1610, Galileo Galilei pointed his new telescope at Jupiter and saw 3 little stars in a neat line beside it, then a 4th. Night after night they moved, but they never left Jupiter. They were circling it. It is difficult now to feel how radical that was. Here it was direct, visible proof that not everything in the heavens revolves around the Earth. Those 4 moons, Io, Europa, Ganymede, and Callisto helped end an entire model of the universe, and each has since turned out to be a world worth the journey in its own right. Io, the innermost, is the most volcanically active body known anywhere. Caught in a permanent gravitational tug-of-war between Jupiter and the outer moons, it is kneaded like a ball of clay, and the friction keeps its interior molten. Hundreds of active volcanoes stud its surface, some throwing fountains of sulfur hundreds of kilometers into space, and the whole moon is painted in yellows and oranges and blacks, a world perpetually turning itself inside out. Europa, the second, is Io's opposite, a smooth globe of ice, laced with long rust-colored cracks, one of the smoothest solid surfaces in the solar system. The smoothness is the clue. Beneath a few kilometers of ice, Europa hides a global ocean of liquid salt water, kept warm by the same tidal kneading that torments Io, and that hidden sea is estimated to hold about twice as much water as every ocean on Earth combined. Dark material, staining the cracks, suggests the ocean touches the surface from time to time. Of all the places we can reach, Europa is among the most likely to host life of some kind, and a spacecraft named for it, Europa Kuiper, is on its way there now, due to arrive at the end of this decade. Ganymede, the third, is simply the largest moon in the solar system, larger than the planet Mercury, a world of ice and rock with its own magnetic field, the only moon that has one, and evidence suggests yet another buried ocean. Callisto, outermost of the four, is the quiet elder, the most heavily cratered world known, its dark ice recording for billion years of impacts with almost nothing erased, a museum of the early solar system. Beyond the big four, the count of Jupiter's known moons has passed 90 and keeps climbing as surveys sharpen, most of them small captured bodies swarming in wide, tilted orbits. Jupiter has one further role in the story of the solar system. It stands guard. Its gravity deflects and captures wandering comets and asteroids that might otherwise fall toward the inner worlds. In July 1994, humanity watched that guardianship in action when a comet called Shoemaker-Levy 9, torn to fragments by a previous close pass, struck Jupiter piece after piece over 6 days. The impacts left dark bruises in the clouds, and some of those bruises were larger than the Earth. It was the first collision between solar system bodies ever witnessed, and it landed on the planet whose pull most often takes the hit. We leave the king behind now. Ahead, nearly twice as far from the sun, is the world almost everyone, if asked, calls the most beautiful. When Galileo turned his telescope on Saturn, months after discovering Jupiter's moons, what he saw made no sense. The planet seemed to have handles, or ears, or two smaller companions fixed at its sides. His telescope was too weak to resolve the truth, and 2 years later, when he looked again, the handles had vanished entirely, which unsettled him badly. He never learned what he had seen. It took nearly half a century before the Dutch astronomer Christiaan Huygens, with better optics, solved it in the 1650s. Saturn is circled by a ring, thin and flat, and touching the planet nowhere. The handles had vanished for Galileo because the rings, seen exactly edge-on from Earth, all but disappear. That edge-on disappearing act is the single most astonishing fact about them. Saturn's rings span about 280,000 kilometers from edge to edge, 3/4 of the distance from the Earth to the Moon. Their thickness, in most places, is about 10 to 30 meters. Not kilometers. Metras. Scaled down, a structure with those proportions would be a sheet of paper more than a kilometer across. The rings are, proportionally, one of the flattest things known to exist. They are not solid. Seen close, the rings dissolve into countless individual objects, each on its own orbit. Particles of nearly pure water ice, from grains of dust up to lumps the size of a house, occasionally a small mountain. They jostle and collide gently, shepherded into bands and gaps by the gravity of small moons. And they are bright because fresh ice is bright, throwing back sunlight from a billion tumbling mirrors. Where the material came from is still argued over. A shattered moon, a comet torn apart, leftovers from Saturn's formation. There is even evidence the rings are temporary, raining slowly down onto the planet, and that we are lucky to live while they are at their best. The planet inside the rings is a gas giant like Jupiter, second in size, about 116,000 kilometers across, 9.5 Earth side by side. Its banding is softer, its colors muted golds and butterscotch under high haze. It turns nearly as fast as Jupiter, a day of about 10.5 hours, and at its north pole it holds one of the strangest sights in the solar system. A jet stream bent into a nearly perfect hexagon, a six-sided storm pattern wider than two Earths, spinning steadily for as long as we have been able to observe it. The physics of standing waves can reproduce it in a laboratory tank, yet seeing geometry that clean on a planet never stops being uncanny. Saturn is also, famously, the least dense planet, lighter for its size than water, and the old classroom line is true as far as it goes. Given an impossibly large ocean, Saturn would float. That is illustration, not prophecy, but it says something real. This enormous world is mostly a deep sigh of hydrogen. Around it orbit more than 140 known moons, and two of them belong among the most remarkable places we have ever explored. Titan, the largest, is bigger than the planet Mercury, and it is the only moon in the solar system with a dense atmosphere, a nitrogen sky half again as thick as Earth's at the surface. That atmosphere hides the ground under an orange smog, and for decades no one knew what lay beneath. In January 2005, a small European probe, named Huygens, after the man who understood the rings, parachuted down through the haze for 2.5 hours and landed. It came to rest on a plain scattered with rounded pebbles, and the pebbles are ice, hard as granite in the cold, and they are rounded because liquid once tumbled them. Titan, at 179 degrees below zero, runs a full weather cycle with one substitution. Methane plays the role of water. Methane clouds gather. Methane rain falls. Rivers of it carve channels to the north, where it pools in lakes and seas of liquid methane, some, like Krakenmeer, larger than the Caspian. It is the only world beyond Earth with standing liquid on its surface, an eerie, frigid mirror of home. Enceladus, by contrast, is tiny, about 500 kilometers across, and it is the whitest world in the solar system, coated in fresh snow. The snow is the giveaway. In 2005, the Cassini spacecraft found geysers at its south pole, over 100 jets blasting water vapor and ice crystals into space through long parallel cracks in the crust. The plumes come from a salty ocean of liquid water beneath the ice, and Cassini flew directly through them, tasting salt, organic molecules, and grains of silica that speak of hot vents on that ocean's floor. On Earth, hot vents on the seafloor swarm with life. Enceladus vents the same chemistry into open space, where a spacecraft can simply catch it. Some of Saturn's outermost ring, the faint E ring, is nothing but the falling spray of this one small moon's fountains. Cassini itself deserves its epitaph in any account of Saturn. The spacecraft orbited for 13 years, discovered the plumes, landed Huygens on Titan by proxy, and rewrote the textbook on the rings. By 2017, it was running out of fuel, and its operators faced a choice. An uncontrolled derelict might someday drift into Europa like Enceladus or Titan and contaminate them. So they steered it into Saturn. On the 15th of September 2017, Cassini entered the atmosphere at 34 kilometers per second, transmitting until the air tore it apart and became part of the planet it had studied. Among the images of its final year is a photograph looking back through the rings at a small, faint point of light. The point is Earth. Past Saturn, the solar system grows dark and quiet, and the distances stretch. The next world was not even known to exist for most of human history. Every planet we have visited so far shines bright enough to see with the naked eye, and so all of them have been known since before history. From the beginning of sky watching to the spring of 1781, the solar system ended at Saturn. Then a musician in the English city of Bath doubled it. William Herschel was a German-born organist and composer who taught music by day and, by night, built telescopes in his back garden, grinding and polishing the mirrors himself, sometimes for 16 hours at a stretch while his sister Caroline fed him by hand so he would not have to stop. His mirrors were the finest in England, better than the professionals. On the night of the 13th of March, 1781, surveying stars from his garden, he came upon an object that showed a disk where stars show only points. He thought at first it was a comet. The mathematics said otherwise. The object was moving in a nearly circular orbit, far beyond Saturn. It was a planet, the first ever discovered, and with one observation the known solar system was twice as wide as it had been the night before. Herschel, angling for a royal pension, tried to name it George, after King George III, and for decades British almanacs listed a planet called the Georgian star. The rest of the world declined, and tradition eventually settled on Uranus, the Greek god of the sky, father of Saturn, as Saturn was father of Jupiter. The world itself is an oddity of the deepest kind. It orbits lying on its side. Every other planet spins more or less upright as it circles the sun. Uranus's axis is tipped 98 degrees past horizontal, so it rolls around its orbit like a barrel. Something enormous probably struck it early on, a body the size of the Earth or larger, and knocked the whole planet over. The consequences for its seasons are extreme. Uranus takes 84 years to circle the sun, and because of the sideways tilt, each pole spends 42 years in continuous sunlight followed by 42 years of continuous dark. A single polar night there outlasts most human working lives. Uranus belongs to a different family from Jupiter and Saturn. It is an ice giant about 51,000 kilometers across for Earth side by side. Its bulk made not mostly of hydrogen, but of a hot, dense fluid of water, methane and ammonia wrapped around a rocky core. The methane in its high atmosphere swallows red light and gives the planet its color, a pale, almost featureless blue-green, the softest color in the solar system. It is also, oddly, the coldest planet. Despite lying closer to the Sun than Neptune, Uranus's upper atmosphere has been measured at 224 degrees below zero, the lowest planetary temperature known, as if the ancient collision that tipped it over also let its inner heat escape. Only one spacecraft has ever been there. Voyager 2 swept past in January 1986, a single day of close observation in all of history, and found a serene, nearly blank globe, 2 new rings, and a flock of small new moons. The rings had been discovered from Earth in 1977, almost by accident, when astronomers watching Uranus pass in front of a star saw the starlight blink several times before the planet arrived and again, symmetrically, after it left. Thin, dark hoops of ice and dust, nothing like Saturn's bright sheets. The moons of Uranus carry the loveliest naming convention in the sky. Instead of gods, they are named for characters from Shakespeare and from Alexander Pope. Titania and Oberon, Ariel and Umbriel, Ophelia, Juliet, Desdemona, Puck. The strangest of them is Miranda, a small moon that looks stitched together from mismatched pieces, its surface a patchwork of ridges, ovals, and abrupt seams, as if it had been broken apart and reassembled. Along one fault stand Verona Rupees, a sheer cliff that may be as much as 20 kilometers high, perhaps the tallest cliff in the solar system. In Miranda's feeble gravity, a stone dropped from its summit, and this is illustration, would fall for a good 8 minutes or more before reaching the bottom. Uranus has kept most of its secrets. One brief flyby, for decades ago, is all the close attention it has ever received, and astronomers routinely place it near the top of the list of worlds owed a proper visit. For now it rolls on, through its 40-year seasons, dim and patient, at the edge of naked-eye visibility, exactly where Herschel's homemade mirror found it. One planet remains. To find it, astronomers did not need a telescope first. They needed a pen. After Uranus had been followed across the sky for a few decades, a problem emerged. It would not keep to its schedule. Newton's laws predicted its path with exquisite precision, and Uranus kept drifting away from the prediction, a little ahead for years, then a little behind, as if some unseen hand were pulling at it. A young French mathematician named Urbain Le Verrier took the discrepancies seriously. If the laws of gravity were right, then something massive and unknown was tugging Uranus off course. And from the pattern of the tugging, he set out to calculate, purely on paper, where that unknown thing must be. Months of computation produced a position in the sky. Le Verrier sent it in a letter to Johann Galle, an astronomer at the Berlin Observatory, who received it on the 23rd of September, 1846, and pointed his telescope that same night. Within an hour, less than 1 degree from the predicted spot, there it was, a small blue disk that appeared on no star chart. The astronomer François Arago put it best. Le Verrier, he said, had discovered a planet with the point of his pen. Neptune is the outermost planet, 30 times farther from the Sun than the Earth, 4.5 billion kilometers out. Sunlight takes over 4 hours to reach it. It is Uranus's near twin in size, another ice giant, about 49,000 kilometers across, but no one would mistake one for the other. Where Uranus is pale and placid, Neptune is a deep, saturated blue, and it is violent. For reasons still not fully understood, this dimmest of the planets, running on the least sunlight, produces the fastest winds in the solar system, measured at up to 2,000 kilometers per hour, several times the speed of Earth's worst hurricanes, in air 200 degrees below zero. Nearly everything we know of it up close comes from a single encounter. In August 1989, Voyager 2, 12 years out from Earth, and finished with Jupiter, Saturn, and Uranus, made Neptune its final port of call. It found bright cirrus clouds of frozen methane casting shadows on the blue deck below, and a vast storm the size of Earth, promptly named the Great Dark Spot. When the Hubble telescope looked again 5 years later, the spot was gone, and others have since formed and faded. Neptune's storms, unlike Jupiter's centuries-old survivor, live and die within years. At noon on Neptune, and this is imagination again, the light would not be darkness. The sun there still shines hundreds of times brighter than the full moon does on Earth. It would look like the harshest and smallest of spotlights, a brilliant point too small to show a disk, casting a pale, sharp-shadowed twilight over the endless blue cloud tops. Neptune's great companion is Triton, a moon slightly larger than Pluto, and Triton is a foundling. It orbits backwards, opposite to Neptune's spin, the only large moon in the solar system that does, and that single fact tells its story. Triton did not form here. It was born in the icy population beyond, and was captured whole when it strayed too close. It circles its adopted planet in a perfect but reversed orbit, slowly spiraling inward over billions of years toward eventual destruction. Voyager 2 found its surface to be one of the coldest ever measured on any world, 235 degrees below zero, and yet not dead. Dark plumes rise kilometers above the frozen nitrogen plains, geysers on a moon where nitrogen itself is stone. One last measure of Neptune's distance. Its year, one circuit of the Sun, lasts 165 Earth years. In 2011, Neptune finally completed its first full orbit since the night Galle first saw it. Everyone involved in its discovery had been dead for more than a century before the planet came back around to where it started. Past Neptune, the classical solar system ends. What lies beyond was within living memory, entirely unknown. In 1930, an observatory on a mesa in Arizona, a 24-year-old assistant named Clyde Tombaugh was doing some of the most tedious work in astronomy. Tombaugh was a farm boy from Kansas who had built his own telescopes out of scrap, grinding mirrors in a pit dug behind the family farmhouse, and had mailed his drawings of Jupiter and Mars to the Lowell Observatory hoping for advice. They offered him a job instead, photographing the sky, plate after plate, hunting for a suspected planet beyond Neptune. His instrument was a blink comparator, a machine that flips rapidly between two photographs of the same star field taken nights apart. Stars hold still under the blinking. Anything that hops has moved. On the 18th of February, 1930, comparing plates from January, Tombaugh saw a faint speck hop. He checked it, and checked it again, and then walked down the hall and said, with Kansas understatement, that he had found the planet. The discovery made headlines around the world, and the name, Pluto, god of the underworld, was suggested by an 11-year-old English schoolgirl named Venetia Burney over breakfast. Pluto turned out to be small, smaller than anyone expected, smaller in fact than our own moon, just 2,400 kilometers across. And in time it turned out not to be alone. Beginning in the 1990s, astronomers found other icy worlds in the same deep region. First a few, then hundreds, then thousands. The region acquired a name, the Kuiper belt, a second belt of leftover worlds far vaster than the asteroid belt, stretching from Neptune's orbit outward, a ring of frozen bodies that never gathered into a planet. Some of Pluto's newfound cousins are nearly its own size. One, Eris, is slightly smaller across, but heavier. Another, Haumea, spins so fast it has stretched into the shape of an egg. When the count kept rising, astronomy faced a choice, and in 2006 it voted to call Pluto not the ninth planet, but the first and brightest of a new class, the dwarf planets, king of the Kuiper belt. Many people never forgave the demotion. Pluto, indifferent, remained exactly what it had always been. And what it is, we only learned in 2015. A probe called New Horizons, the fastest spacecraft ever launched, spent 9.5 years crossing the entire solar system, all the distances of this journey, to reach Pluto, and swept past on the 14th of July, 2015. Aboard it, in a small container fixed to the hull, rides a portion of the ashes of Clyde Tombaugh, the Kansas farm boy on his way past the world he found. Everyone expected a dead, battered ball of ice. Pluto embarrassed the predictions. The pictures showed a complex, active, strangely beautiful world, its most famous feature a vast, smooth, pale plain in the shape of a heart, visible from 1 billion kilometers away. The heart's western half, Sputnik Planitia, is a glacier of frozen nitrogen the size of Texas, and it is alive in slow motion. The nitrogen ice churns in great convection cells, turning the surface over every few 100,000 years, so that this one plain, on the far edge of the solar system, has no craters at all. Around its shores stand mountains 3.5 kilometers high, and they are made of water ice because at Pluto's temperatures 230 degrees below zero, water ice is as rigid as granite and plays the role of rock. And when New Horizons looked back after the flyby, with the sun behind Pluto, it saw the little world ringed in dozens of fine layers of blue haze. Pluto has a sky. It also has a companion, unlike sunlight at Pluto is 1,000 times fainter than at Earth, and yet daylight there is not what you might imagine. High noon on Sputnik Planitia is still hundreds of times brighter than a full moonlit night at home, about as bright as Earth a few minutes after sunset, light enough to read by a long, permanent, silvery dusk. New Horizons kept going, as everything on this journey keeps going, and on New Year's Day of 2019, it flew past a small Kuiper belt object named Arrokoth, 6.5 billion kilometers from home, the most distant world ever visited. Arrokoth looks like a snowman, two soft, reddish lobes, gently fused, utterly unchanged since the solar system's first days, a leftover snowflake from the original storm. Out here, the sun's family thins away gradually, world after smaller world, into the dark. But the sun's reach ends at a real border, and one human machine has already crossed it. All through this journey, something has been traveling with us, unmentioned since the very first chapter. The solar wind, the thin breath of charged particles flowing off the sun in every direction. That wind blows past every planet we have visited, past Pluto, past Arrokoth, on into the dark, carving out an immense bubble in the gas between the stars. Astronomers call the bubble the heliosphere, the region where the sun's wind and the sun's influence still rule. The bubble has a wall. Far out, the wind slows, piles up against the interstellar medium, and finally stops at a boundary called the heliopause. Roughly 120 times the Earth's distance from the sun inside is the sun's weather. Outside is the wind between the stars, the mingled breath of other suns. It is as good a definition as any of where the solar system's active domain ends, and we know precisely what crossing it looks like because we have done it. In the summer of 1977, engineers at the Jet Propulsion Laboratory launched two identical spacecraft, Voyager 1 and Voyager 2, to take advantage of a rare alignment. Once every 176 years, the four giant planets arrange themselves so that a single spacecraft can be flung from one to the next, each flyby adding speed for free. The Voyagers took the grand tour, Jupiter's storms, Saturn's rings, and for Voyager 2 alone, Uranus and Neptune as well. Nearly everything this hour has described about the outer worlds we first saw through their cameras. Each carries a message. Bolted to each spacecraft side is a gold-plated phonograph record containing sounds and images of Earth chosen for anyone or anything that might someday find it. Greetings in 55 languages, the sound of surf and rain and a human heartbeat, birdsong and whale song, Bach and Beethoven and Chuck Berry, a kiss, a baby's cry, the brainwaves of a young woman in love. A message in a bottle, thrown into an ocean with no far shore, by a species that could not resist trying. On the 25th of August 2012, Voyager 1, then 18 billion kilometers out, felt the solar wind around it die away and a new pressure take its place. The particle counts changed. The surrounding plasma thickened to the density of interstellar space. After 35 years of flight, it had crossed the heliopause. A machine built by human hands was sailing, for the first time, in the space between the stars. Voyager 2 made its own crossing 6 years later, giving us the measurement twice. Both are still alive as of this recording, which is its own quiet miracle. Each runs on a small nuclear power source that fades a little every year, and one by one their instruments are being switched off to save warmth and power, an orderly, gentle shutting down of the house. Their radios transmit with about 20 watts, the power of a refrigerator bulb. By the time Voyager 1's signal has crossed the more than 24 billion kilometers home, almost a full light day of distance, it arrives almost unimaginably faint, and yet the great dish antennas on Earth still find it, every day, a whisper from outside the bubble. Within a handful of years the power will finally fall too low, the last instrument will sleep, and the calls home will stop. The journey will not. Nothing out there can stop it. Voyager 1 is headed, in the long run, in the general direction of a small star called Gliese 445, and it will pass within a couple of light years of it in about 40,000 years. Long after the pyramids have worn away, the two Voyagers, silent, intact, still carrying their golden records, will be drifting among the stars, quite possibly the longest-lasting objects human beings have ever made. Even the heliopause is not truly the end of the sun's household. Far beyond it, astronomers are confident, lies the Oort cloud, a vast, sparse shell of trillions of dormant comets, the outermost debris of the solar system's formation, extending perhaps a significant fraction of the way to the nearest star. No one has seen it directly. We know it by the comets it occasionally drops toward the sun. The Voyagers will be crossing it for tens of thousands of years. Somewhere out in that thin swarm, gravitationally speaking, the sun at last lets go. Remember the front door? The sun a doorway. The Earth a coin 2 city blocks away. Neptune across town. Voyager, after 50 years of flight, 36 kilometers down the road. And the nearest of the night's stars, at that same scale, farther away than once around the entire Earth. Every single star you have ever seen in the sky is another sun at that kind of distance. And there are several 100 billion of them in our galaxy alone, many with doorsteps and coins of their own. Seen from out here, from the cold past the edge of the bubble, the whole of this journey, the boiling star, the cannonball planet, the acid twin, the blue world with its one oversized moon, the rusted deserts, the stone borders, the striped king and the ringed wonder, the tipped-over sky god, the mathematician's planet, the little heart-marked world in the dark, all of it huddles close around one modest, steady, middle-aged star, partway out along one arm of one spiral galaxy. The light now leaving the sun's surface began its slow climb from the core before human history began. It will slip past the planets in hours, cross the heliopause in less than a day, and then go on, out into the space between the stars, steady and unhurried, for as long as there is anywhere left to shine.